I'm going to talk about a design that's been, I guess, many years working with Airflow. So my name is Stephen Woods. I am the Director of Software Engineering at Zealous. And at Zealous, we're responsible for data in the healthcare space. So that includes member data, hospital data, and doctor data. So me and my team work with this data to create services around it and do data orchestration around it. I started using Airflow back in 2019 on version 1.10. And back then there was no configuration and parameters. So we got pretty creative on how to dynamically scale our DAGs. And since then, we've gone through many iterations on how to improve our designs, and I'm excited to share what we came up with. And if you are using this design, I would like to hear how you have used it and how you improved upon it. If you are not using it, I would encourage you to try it. Okay, in this presentation, I'm going to talk about the initial DAG design that we're trying to work through, and some of the common anti-patterns like hard-coded logic, duplication, rigid sequencing, our refactoring strategy, how do we make it better using the configurations and parameters, designing for flexibility, right? There's multiple ways to receive data nowadays with Airflow, so we can target batching, streaming, and ad hoc workflows. And there are pros and cons to this design workflow, and I'm going to discuss that. So I decided to pick a different project rather than dealing with JSON files or PDF files or CSV files. So this concept could be used across many different, use cases. We primarily deal with JSON files and CSV files. So we've put this into our DAG design. But I'm going to focus on doing a project about animal images. So what we're trying to do is create a workflow where we gather animal images daily. And so we're going to start off with a set of 4 animals. This is the first iteration of our DAG design. And we're going to do something simple like grab the image. Maybe we're going to use a Lambda function to do this work for us. And we're going to take that image, store it in an object store like Amazon S3. And we're going to perform a process around it, standardize the image size, maybe convert it to a format so we're ready to process the image and create a video out of it or a slideshow, whatever we want to do. Here is my initial DAG design, right? I always like to start off with an empty operator as a start and a complete operator at the end, so it has a nice flow. But as you can see, what we want to do is trigger zebra download. So you'll notice in this graph, they're all the same. It's just the name of the animal is different. So the operations being performed on them are all the same. They're just operating on a different animal. So what we want to do first is download the zebra image. So this could be a Lambda function that gets kicked off. My next DAG checks to make sure that file exists on S3. After the file exists, then we want to process this image. So we'll resize it. We'll convert it to a JPEG, and then we'll store that metadata in a database, and then we'll send out a notification. That could be an email, that could be Slack, and then that completes the DAG. So our initial design was this all has to get done together in a group and complete successfully. Described all of the, patterns there, and we'll move on to what are some of these issues. If you have a DAG design like this and this is your use case and you're not looking to scale it, it should work perfectly fine. In our case, we wanted to add more animals, and here are some of the, issues around that, right? So I call this design repetitive task rows. So every row is exactly the same. It's just a different animal. So more rows is more code, right? So I've got to add code for every single animal I'd like to add. So that creates a pull request and a deployment. It's hard to run this concurrently and isolate the failures. It doesn't really scale, right? If I need more animals, this graph is going to get bigger, and it's just harder to view. It's harder to maintain the code, and depending upon how your tasks are set up, one failing task row can either break the whole DAG run or cause it to just be waiting for one of these rows to complete. So this is what I eventually ended up with as I was adding more animals to our DAG design, right? It's something where it gets really complicated to view. And I'm sure you've seen this somewhere on the internet. I found many examples, but as you start adding more and more, this is what the graph looks like, right? The code grows linearly with every animal. It's just harder to maintain. It's harder to isolate and retry failures for a single animal. It increases the DAG execution time and complexity. And obviously, the visuals becomes very, very difficult to view. Okay, so this is what I wanted to review on, when something does go wrong. Again, depending upon how you have your DAG set up, in our original use case, we wanted everything to complete successfully before the next DAG run would get kicked off. So if the cat image is failed and is having trouble getting past that task, it'll slow down the next kickoff to your DAG. So then you have to come in here, retry it, and start clearing out certain tasks. Even if you have retries, you'll end up with something like this at some point in your journey when you create something like this. So with DAG concurrency 1, and you're at this state, it could take longer to get your next DAG run to kick off. It could even block it, depending upon if you have a long kind of center or wait time, and that'll slow down your operation. So the recommended solution at this point is to create 2 different DAGs, and I like to call them the trigger DAG and the processor DAG. So the trigger DAG just runs on a schedule, right? It's just a lightweight DAG that has the configuration on the right side. So we're saying, here are the animals I'd like to process using this configuration. So this DAG passes the parameters to the processing DAG, and you can turn this DAG on and off. It separates out the responsibility of automating it versus processing it outside of Airflow. So the processor DAG, its only responsibility accepts the parameter of an animal. It has no schedule and only runs when it's triggered. It could be triggered by many different ways. By DAG 1, as you see in this example. Manual runs with parameters, so I can go to the Airflow UI. I can fill out the DAG parameters. I can run it manually. Or you can be triggered via API. So this supports ad hoc requests, and it's also flexible for processing. You turn it on and off, and we can generate other animal pictures on the fly, or we can redo an animal picture on the fly. So I'm going to go a little bit more into the trigger DAG and some of the options there. So we have 2 different types of execution modes, group processing and individual processing. So if I want to process them in a group, I want to make sure that all of my animals get processed before I move to complete. And then you have the individual processing where you don't necessarily care when they get done, you just need them to get done. So you can use the trigger DAG run operator to achieve this. Again, it just depends on your use case. In some cases, if you have 4 CSV files and you need these 4 to be completed before you run on to your next step, you'd want to process them in the group. Or if you just needed the files processed at any given time, you wouldn't need to wait. So using this configuration, there is a variety of ways to set it up. I've kind of pointed out 3 of them. The single one I don't really have displayed here. It's basically going to be 3 tasks. It's going to be 1 start and complete, and then there'll be a Python operator which just says, I'm going to trigger this animal on this DAG, and I don't care if it completes or not. The second one is more static, which is similar to the first DAG, where the graph view gets a little bit longer, but you get to visually see which animals are completing. So I don't really recommend that one. I guess the third one is what I would recommend, using the dynamically task maps, where you can have in the graph view all of the animals inside of that graph view, and you can scale that out at any given time. The DAG number 2, the processor DAG, responsible for processing the config. So its only responsibility is to get those parameters and start working on them. It doesn't run on a schedule. It only runs when it gets triggered. Again, this could be started by another DAG. It could be manually run with parameters or an external process like an API call. In our company, we run an internal applications, so we use Airflow as kind of our back-end processor to run long-running jobs. So we leverage this a lot across using the web page to trigger the jobs. So this is something we've incorporated in our day-to-day operations. It's also easy to extend, right? You can add new configurations via Airflow variables, or you can possibly even add the configuration in some sort of data store where it reads all the animals. It's flexible and dynamic, right? If I want to add more animals, I don't need a PR and I don't need to do a deployment. I can just modify the variable or the database configuration. So in this DAG design, the processor just focuses on the operations, right? You don't see any definitions on what animals work on, but during the DAG run view, you can click on, or at least you can view in the DAG run details page, which animal has been processed during that DAG. This is also great for flexibility. You can control how many DAG runs you want, how many tasks you want, so you can really scale it up or you can scale it down depending upon your use case. So again, downloading the image, ensuring it's complete, doing our resizing, storing the metadata, and then sending out a notification if we needed to via email or Slack or whatever. And this gives us the opportunity to have full control over our DAG and how often it runs and what concurrency it runs at. So now that we have this design, it supports a diverse range of workflows. So I talked about in the beginning a batch design, which is let's run everything on a nightly schedule. Let's process the full set of animals in a batch, or JSON files or CSV files. So this is best for when the freshness isn't critical and daily updates are sufficient. Streaming, right? So with our processing DAG, we're able to receive data on the fly from either a Kafka or Kinesis or an SQS or some sort of message broker system where we can consume that and trigger the DAG via that method. So we can just take on any animal that we wanted to, for that matter. And ad hoc, this is something in our organization we use a lot. We have a web page where we can trigger jobs through the configuration of these parameters. So we can use the Airflow's API calls, and that'll trigger the process. So this doesn't rely on a fixed schedule, only when a user requests these images to be downloaded. Okay, so depending upon your use case, there are some pros and cons that I would like to talk about in this design. The pros, of course, for me, is scalability. I can add and remove configurations, animals. I don't need to add or update my DAG code. I can optimize my execution depending upon the size of my Airflow instance. I can control DAG concurrency, task concurrency, parallelism, just to see how much workload I can get done. I also separate out the responsibility. And this is one of my favorite things. As our team grows, I want them to be responsible, like the DAG to be responsible and really good at one thing. So this makes it so we can focus on that DAG, make sure that code is reliable and strong, and it just focuses on what needs to do. So this makes the code base cleaner and easier, and it allows us to have our engineers focus on improving that DAG code and focus on what needs to get done there. Like I said before, no code changes needed because you're just adding a configuration or parameter. Simplified troubleshooting, right? So if it's not a whole DAG run that fails, it's just an animal that fails for that DAG run. So we can quickly spot, maybe the cat parameter is not working for that day for whatever reason, but we can see it in the grid view what's going on there. And my favorite is flexible execution, right? So we have one DAG being really good at something. We can have other DAGs kind of mix that in there. And then now we are reusing DAGs across our Airflow infrastructure. So some of the cons that I thought about were splitting the code base, right? So that could be a con if you wanted all of your DAG code in one file. So that could be a con, depending upon use case. Limited validation. You could probably add in rules, but for now, we don't know if what they're sending is actually an animal, right? If it's even going to succeed at this point. And then, again, fragmented visibility. You're going to have to go to multiple DAGs to kind of see how the workflow went.